Uh, it is the second lecture of the electrostatics, and in this lecture we are going to discuss about the properties of the charge. And what are the properties basically? The property of a charge. First property, charge can be transferable. Trans Charge is transferable, means we can transfer the charge, but there is a condition. The condition is you can transfer the charge uh, from one to other position. uh, they should be localized. uh, Basically you can't transfer the charge anywhere in the world, yeah, anywhere in the universe by mixing it with this. It can transfer to the local places. It means somewhat near to the other object. Charge is basically, this means that charge is transferable from one body to other. It is basically the basic property of the charge. And the second property, charge is conserved. Charge is conserved simply means charge neither be created nor be destroyed. And uh, it is the conservation of the charge, mean you can neither be created nor be destroyed. And basically you can transfer the charge from one place to other place, but there should be condition. It is to the near of the object only. You can't just sitting in the India, and you can't transfer the charge in the USA in within a second. Yeah, it you can't transfer it. Yeah, basically. And the simple thing. And if you transferring any charge, there is a conservation of the charge. It you now never be created, you nor be destroyed. It neither be created nor be destroyed, it simply means. And the second is the conservation of the charge, basic property. The total sum of the charge is conserved. In an isolated system, we simply say that in an isolated system, the total charge remain constant, whatever the charge take place in that system. The basic property. And the third is third is charge is quantized. Charge is quantized means, quantization means discrete set. Means you have the certain values, you have some certain values in which the charge value can lie. Okay, they are not continuous. These are the some continuous curves. The charge would not is not continuous. And basically the quantization means these values are discrete. And simply we show by it by the simple expression, total charge q is equal to plus minus ne, where n values n values are 1, 2, 3, and so on. And e value we have discussed already. And most of the students also know that 1.6 into 10 the power minus 19 coulomb. And simply the number of electrons, the total charge is nothing but simply n into e. N into e means the n value is 1, 2, 3, 4, and goes on. And e values is fixed here. And so these are some discrete value. Yes, it may be e value, it may be 2e value, 3e value, and 4e value, but we can't have e by 2 here, something 3e by 2. these value doesn't lie. It means these values in between them, these values are not allowed. So we simply say that the charge is quantized. Okay, and simple. And the other is other is let me the other is the next property is fourth property. The fourth property simply says that charge is always associated with the mass. Charge is always associated with mass, and it simply means uh, we can't have the charge on a body which do not have any mass. Okay. Can you think of anything that do not have any mass? These are the photons simply. Photons simply the light. The photons are nothing but the some energy packets from which the light is made up. Photons are photons are simply energy packets energy packets and basically light is made up of photons. Light is made up of photons, and simply the photons have no mass simply. So we simply say that the light do not able to carry any charge on it. It simply the gamma rays, alpha rays, X rays, we can't they cannot carry any charge. They are neutral basically. They are neutral because they can't carry any charge because they do not have any mass. The massive bodies, yeah, the bodies having the mass only can have the charge associated with it. Charge can't on the simple massless bodies. Okay, this is the fourth point. And the fifth point, additive nature of the charge. additive Additive nature of the charge, it simply means that you can add the charges simply. Let's suppose you had a plus 1 charge, plus 2 charge, and something like that, plus e charge, and let's suppose minus 3 e charge, plus 4 e charge, and the total charge is nothing but the total charge. You can simply add it simply 1 1e plus 2e minus 3e. But do not forget to carry the negative sign and sign with the charges. It matters a lot. We simply, if we calculate it, we are getting 4e. The total charge is 4e. We simply add the values. Simply, it is additive nature of the charge. We simply add the values. And sixth one and the last one is invariance invariance of the electric charge. It means that the electric charge not vary with the any vary with the velocity of the charges, yeah, velocity of the object. And I think we most of the students know that the relative stick mass is nothing but m is equal to m naught 1 minus v square by c square, and Length also varies with the velocity. Here the velocity term, where the velocity, it simply means the mass quantity is varying with the velocity. Uh, it is the rest. It is the rest mass. It is the rest mass. Uh, it is the length and it is the rest length, and it is the velocity of the object. Velocity of the object. And simply these quantities vary with the velocity of the object, but remember that it does not it affect when the it is relativistic, means the relativistic means then the v is approximate equal to c, that remember it. But I think you know the speed, where c is the speed of light. Okay, c speed of light is 3 into 10 the power approximate 3 into 10 the power meter per second. We got it. And this is the sixth property that we had discussed. But the charge, simply the charge do not vary with the velocity of the object and velocity of the charge. It simply remains invariant, and uh, charge remain the same with the velocity, whatever velocity we have the charge have. Okay, thank you.